What's going on, guys? Welcome back to a brand new video. This is Web Dev Journey, and in today's video we're going to be talking about work queues or task queues, however you know them as, right? I'm going to be referring them as task queues just because I know them that way. So we're going to be talking about task queues. So basically the biggest idea or the main idea for task queues is to avoid doing time-consuming tasks. All right. So let me draw you a better picture. Imagine that we have a app that's an image resizing app, right? So, oops, right here. And then we have our service, right? So if we send an image to go get resized, we're going to be waiting for a while because we know that image resizing takes a while. We're going to be waiting for a while for that service to resize the image. And then after, let's say, I don't know, man, let's just say 10 seconds. I'm pretty sure that's a bit too much, but after 10 seconds, it comes back saying that, hey, here's your image, right? Now, this right here is a problem. We don't want this because now our service is just hanging around waiting for that request to complete, right? Which we don't want. We really want to avoid that as much as we can. So this is where a time or a queue comes into play. So imagine that we have a queue right here, right in between these guys. Right, this is our queue. So our app is going to send an image request or image resize request. The queue is going to take that up. Okay, we got the message, and it's going to send a message back saying that, hey, we got the message. Everything is good. We'll just wait. I mean, everything is good, right? So now the app is free to do whatever it wants. It's not just waiting on that request. Now, as far as this, now this message gets sent to our service, and this is going to take some time, but it doesn't really matter now because now our app over here is free to do whatever it wants. It's not just waiting no more. Okay, and this is basically what we want to tackle, right? Just to save us from trying to wait for that long time-consuming task to be completed. All right, so let's get coding, and you'll figure out more and more after we start coding. So what I've done so far is I'm actually splitting these things into folders. So we have this hello world folder, and now we're working on the work queues or task queues folder, right? And in here we have a send task and consume a task. Basically, we could just call this the worker because this is going to be working, right? Consuming the tasks. So anyways, the code right here that you see is literally the same code as in the last video. I have not changed anything at all. So if you did not see the last video, I highly recommend you see the last video before you get into this one, because we're going to be modifying the code in here. So the first thing we're going to be doing is renaming our queue to, let's say, task. And our message is going to be different. I do want to say this right now before we get any further. I don't really have a time-consuming task, obviously, like image resizing. I don't have a service that does that. So the way we're going to accomplish a time-consuming task is by setting a set timeout. All right, so we're going to be playing around with set timeouts. So that way we could say that this task is going to take 4 seconds or whatever. So the way we're going to be doing that is by user input. So in the modules of RabbitMQ, I will have that linked in the description below, so that way you can see what I'm talking about. In the modules in RabbitMQ, they have this little thing right here where it says that, hey, we're going to be grabbing the user's input if we decide to put anything in there, or the standard hello world input. That's it. And the reason why they're grabbing the user input is because they have this thing where it's actually pretty cool. They have this thing where if you put in 1 dot, that task is going to take 1 second. If you put in 2 dots, that task is going to take 2 seconds. You could just write 10 dots, the task is going to take 10 seconds. And that's why we're doing user input for those dots. So yeah, anyways, you'll see this in play once we start consuming the task. Anyways, so we did the task or the name, the queue name, and then the message. Another thing we want to do is actually make our queue durable. So instead of false, we're going to say true. As you know, durable, this just means that if our system or if our RabbitMQ instance restarts, our queue is going to get respawned again. It's going to create this queue right off the bat, which is a good thing, okay? Especially when you're working with work or task queues, right? Also, the messages. We actually want to make the messages persistent. Durable, like we said in the last video, does not mean persistence. Once we send a message to the queue, we want to add an option here in saying that we want this message to be persistent. meaning that, oh, true, sorry. Meaning that if our instance, our RabbitMQ instance does restart, it's going to recreate the queue and also have our messages, right? Since this is going to be writing it in disk. And we'll see what's going on in a bit in the GUI interface right here, okay? We'll see that being put into play. Now let's focus our attention to the consume task. We're pretty much done with the send task. That's pretty much it. So let's go to the consume task. So the task queue name is going to be task. We also want to make this durable, so true. And then when we're consuming the task, the message is different. Remember, we're grabbing that user input solely for those dots, right? So we want to get the number of dots that the user inputted, and the RabbitMQ already has something like that, so I'm gonna just paste it in here. So they just did that for us. This is going to give us the number of dots they put in there, and we're gonna add it right here. So seconds, if you put 3 dots, it's going to have 3 in here. And then after we receive the message, we're going to do a set timeout of seconds times 1000, because milliseconds, so we already know how this works. There's no need for me to explain. And what we're going to do right here, I'm just say console.log. I'm gonna say done resizing image, like that. Okay, so that's pretty much it. We're going to do more often, but let's just focus right now at this. So all we did right now was make our queues durable and made our messages persistent, and that's pretty much it. The messages is a little bit different, which is not too much, right? All right, let's get this into play. Let's create a task. So down below, let's run the send task module. So node module file send task. Oh, we need to get in our file first, or folder. So work, there you go. And then node send task. Now before we consume it, let's see what's going on over here. And we should see one pop up. There it is. Hey, hold on. Sorry about that, I'm tired. Anyways, you're gonna see that it's purplish. It's this one right here. Now we're writing to disk. It says right here disk, right? It's because the reason why we're doing that is because, remember, we're making it persistent, right? So it needs to write it somewhere, so that way in case something happens, we have it on disk, and that way it's going to recuperate our message, right? So that's why it's writing it in disk. And you can see that one is ready and total in one. We go to queues and we got the queue task, our features, it's durable, and we also have ready and total, right? Nothing new here. The only new thing is this purple, which is disk write. Now let's consume it. So over here, a new console. Let's go to cd work queues, and then let's do node and run the consume task, or task, right? So we're done. Hello world, and over here you're gonna see that it's going to spike. Hold on, it's going to take a little while. It should anyways. Well, that happened really quick. It didn't even know over here didn't even do anything. But as you can see right here, we've don't have anything, so our message is gone. If you check over here, there you go, nothing in the task queue, which is a good thing, right? So this is still working. Now, another cool feature about working with task queues is that the round robin dispatching. Now, what is that exactly? By the way, hold on, let me just had to rename these because they were like, anyways. So what is a round robin dispatching? So let me actually draw you another picture because it's much more easier if I draw you a picture. You can imagine that, that we have a service right here, right? Whatever. And our app, and we have a task, right? Our queue right here, and it's sending task to this queue. And then we only have one service, right? Now, imagine that we're sending so much tasks that this queue is getting backlogged. There's like too many tasks, right, that are still in the queue. So the good thing about this is that we could scale up, right? We could scale these services, so we could create another service right here and another service right here. Now, what RabbitMQ is going to start doing is, let me actually remove this little thing right here. It's going to start dispatching Man, dude, that sounds weird after saying it so many times. It's going to start giving out tasks evenly. Basically, what I mean is, let's say that this has, I don't know, 7 tasks right inside of it. So it's going to send one right here, and then one right here, and then another one right here. And this is going to go around again. It's going to send another one right here, another one right here, another one right here. It's going to go around again and send another one right here. So the final tally is that this is going to have 3, this is going to have 2, and 2, right? 4, yeah, 7. There you go. Which is a good thing, right? It's trying to spread out the tasks evenly among the services, which is good. And we could actually see that in play if I do, and this is where the dots come in, right? Where the user inputs come in. So let me actually make this a little bit bigger so that way we can see what's going on. Control C, clear this out, and we're gonna create another console. Clear this out, CD into work. All right, so we're gonna create 2 workers. Basically, we're gonna create 2 services that's going to consume tasks, right? So node consume over here, okay, and then node consume right there. So now we have 2 workers or 2 services that's going to consume tasks. Over here, what we're going to be doing is sending tasks. So node send, and this time I'm actually going to use a dot, so I'm gonna use test dot. So this is going to take 1 second, and you're going to see that every time I send in a message or a task, it's going to try to distribute the task evenly. So here we go. Hit there. Let's make another one that's 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, right? And you're going to see that here's 1, test 1, test 2, test 3, test 4, test 5, and then test 6, which is good, right? This is going to give us that, well, it's not going to make our queue backlogged, right? We could scale up our services now, and also is going to start distributing our tasks evenly, which is a really good thing. Now here comes the problem, right? And it's not that big of a problem. And again, I gotta draw you a picture, guys. This is the only way for me to explain it in a very good manner. So imagine you got your app, whatever, it doesn't matter, and you got your queue, and then you got your apps or services over here, right? So let's say that you have a service, insurance, right? You know how this works, right? Let's say this time it gives out two tasks, right? So 2 tasks, 1, 2. Obviously we're using round robin, so it's going to distribute that one right there and one right here. So these both have 1 task each. Now the way it works, because we have this no act true, that means that once this let me scroll down. Once this receives the message or the task, right? So once this service receives a task, it's going to send a acknowledgement back to the queue saying that, hey, I have received the task, so you could just delete that task from the queue. So it's going to delete 1. Here we go. It's going to delete 1, right? All right. And same goes to this one, right? It received a task, and now it's going to say, it's going to acknowledge it. It's going back to the queue saying that, hey, we've received one. You could take it off your queue now. All right. But what if one of these services, bam, a hacker got into it or something, it just goes down, right? What happened to that image that was resizing, right? It wasn't done yet, so we didn't really finish that job. So we just lost that job. We lost that image. And the even worse thing about it is that we don't have that message or the task in the queue anymore because we acknowledged it too soon, which is a bad thing. Now, the best thing that you could do is, get rid of these. Over here. Okay, the best thing that you could do is that we have 2 tasks. They're distributed early. So what you could do is that once you send a task to this service, wait upon it, or to these services, wait until the services are actually done rendering or resizing the image. And then once it's done resizing the image, what you could do is make that service say that, okay, hey, I'm done resizing the image. I have the image. Here it is. I'm showing it, whatever. Right? Make sure that the service acknowledges that, hey, I actually resized the image. It's done. So you could now take off the task from the queue, right? And same for the bottom one, right? Once this is done completely resizing the image. It's going to send an acknowledgement saying that, hey, I'm done. Now you could take off the service. Because now, if this is the case, what we could do is, if this service right here decides to go down, guess what? We still have that message or that task in the queue because we didn't acknowledge it early, right? We were waiting for it to be done and then acknowledge it. But since it got shut down, no more themes, we could spawn up another service over here, right? And then, it'll probably give it off to this one and then just wait until it's done. And then once it's done, it'll tell the queue, hey, I'm done with the service or resizing the image, and then get rid of the queue. This is a little problem that we got to fix, right? And it's not that big of a deal. It's actually very, very simple to do. So basically what I'm trying to say is that we don't want true for NOAC, right? Acknowledgement. We don't want to automatically do this. So what we need to do is set this to false. We don't want to automatically acknowledge our messages, our tasks, right? We want to do this manually. How do you do it manually? So I'm going to actually make this another line. So right here, this is where we're going to do it. So once this is done resizing the image, what we want to do is now send, hey, channel, we are acknowledging it's called Ack, this particular message, the message that came in, we are acknowledging that this message is complete. Now you can mark it off the queue, which is what we talked about. This is actually how you do it. It's very, very simple. It's not that hard. And we could actually check that out for ourselves. So what I'm going to do is Control C these. And over here, what I'm going to do is send a task of, let's say 5 seconds, right? There we go. We sent a task for 5 seconds. So over here in our GUI, we should see there we go. We set that. And then there it is. So here it is right here. So we have a publish and then a disk, right? Because we're persistent. So now if you look at the queues, we're going to have one that's ready to consume and we only have one, right? And notice this number right here, unacknowledged is 0 because we haven't even tried to consume it. So let's try to consume it. Over here, we're going to do is consume task, receiving task. And over here, you're going to see that the 0 is going to turn into 1. There it is. We haven't acknowledged it. After 4 seconds, it's going to hit 0. There it is, right? After 4 seconds, it hit 0, meaning that we manually acknowledged it. So we saw that in play right here, which is a good thing, right? We manually acknowledged it once we were done resizing the image, which is a very, very good thing. Now, there's still a little hiccup that we still got to take care of. Let me draw you another picture. I'm telling you guys, pictures is the only way, man. All right, so again, here's our little app, whatever, you already know, and here's our queue, right? And let's say this time we sent in, let's say 3, right? 3 messages, or actually, no, 5 messages, right? It doesn't matter. I'm not going to check these. You already know what happens, right? So we have 2 services right here. And now we already know how round robin dispatching works, right? It's going to try to dispatch the tasks evenly. Since we have 5, this is going to have 3, since let's say that this is going to go first, right? And this is going to have 2, right? So 1, 2, 3, 4, 5, right? So anyways, so the problem comes in right here. Let's say that one of these tasks, this first task takes 10 seconds, second one takes 5 seconds, and the other one takes 15 seconds, right? But over here, the first task takes 3 seconds, and the last task takes 1 second. Now, you might be like, what? I mean, it dispatched it evenly. Yes, it's correct, but good God, look at this. The time, man, the time. This service right here is going to do a hell of a lot of work to try to complete these, right? Especially if the service or the app keeps on sending out requests, right? It's just going to keep on piling, right? You can see this being a bad thing. You're probably like, well, we could just scale up. Yeah, but then again, this problem is going to end up in one of these services again. So you want to get rid of this problem. How do we get rid of this problem where we have this service doing the majority of the work and this service over here is not doing that much work, right? It's just freeloading off of this one, right? I guess you could say. And they call this a fair dispatch, or what we're about to do, they call it a fair dispatch. Now, what do I mean by this? All right, so let me get rid of this stuff right here. And let's say that we have, all right, so we have the 10 second, 5 second, 3, 5, 15, and then 1, right? So the 10-second task is going to go over here, and then the 5-second is going to go over here. So what fair dispatch means is that it's going to send one task at a time. That is it. So once a task is complete, obviously it's going to send out a, hey, I am done. So I am done with the task. There is no more task in my plate. So what it's going to do is mark out the 5, right? It's going to get rid of the 5. And then it's like, okay, so since you don't have no more task, here's another one, right? The 3-second one is up next. So once this is done, it's going to go back. It's going to say, I am done, right? So you can mark that off your queue. And now it's going to send in the 5-second task, right? 5, right? Since it's over 10, this is actually done now. It's going to send an acknowledgement. And then the 1 is going to be sent over here. Here's your task, right? Basically, this makes it even much more, I guess you could say it makes it even fairer? Fair? Is that a word? Fair? More fair? I don't even know, man. You know what I'm talking about, right? And they do this by calling the Prefetch method on the channel. And it's very, very, very simple, all right? So let's actually do that right here. And like I said, everything is in the consume task. So before you even consume anything, what you want to do is prefetch, basically channel dot prefetch. There it is. And you're going to put a 1 in here, all right? So what you're going to be doing is prefetching a task and see, hey, is it good to send off another task? Basically what this is saying is don't dispatch a new message to a service or a worker, whatever you want to call it, until it has processed and acknowledged the previous one that it was working on, which is what I explained, right? So you need to set this up first and then start consuming these things, okay? And I don't think we could see this in action. I don't think so, man, but I'm going to try my best. So what I'm going to do is clear this. We're going to create a worker right here. Clear this and create a worker. So we got 2 workers right here. And what I'm going to do is send a task of 4 seconds and then 2 seconds and then 2 seconds and then 3 seconds and then 1 second. And let's see how fair this is. How fair this is, right? So what was first? What was first? What did I send first? Dude, I don't even know what I sent first. Was it a 4-second one? Yeah, it was a 4-second one, right? So we sent the 4-second. You can see that the 4-second is right here. So this one has a 4-second. So this one right here is 2 seconds, and you can see that the 2-second is right here. I guess it didn't do it, right? And then 2 seconds right here, and then 3 seconds right here. Or it did. Did it do it? I'm not too sure. Honestly, I'm not too sure. All right, let's try this. Let's try to do a 4-second and then 1 second repeatedly. All right, so 4 second and then 4 second. Okay, guess 1. No, it's still going back and forth. Dude, I didn't even save it. Oh my God, I did all that for no reason. Hold on, my bad. Let me clear this out. Clear. Okay, let me clear this out. Clear. I didn't even save it, man. No wonder, dude. I was like, dude, it's doing a round robin. What? Why? All right, here we go. Let's try to do this one more time, all right? So the easiest way we're going to do this is send in a 4-second and then 1 second after that. Okay, let's send in a 4-second and then a 1 second. 1 second. There it is. You see that? So you see that this took 3 seconds or 3 tasks right off the bat before even taking 1 over here, which is a really good thing. That means that this prefetch is working, which is really good. So guys, that is it for this video. And you can see that we don't have anything. Look at all that stuff, man. Like the red is deliver manual acknowledgement, write disk, and publish. Yeah, we already know that stuff. Anyways, that was it for this video, guys. I do want to recap really quick what we've done so far, and this is for the task queue, right? So task queue, basically the main idea for it is to avoid time-consuming tasks. And the way we're going to be doing that is basically making our durable or our queue durable, just in case of system failure or system restart, my bad. And then making our messages persistent, right? Because since this is a task queue, we're going to have tasks in there, and it's going to suck if we lose our task when our I was going to say MySQL, but when RabbitMQ restarts, right? So we want to make those messages as persistent as possible. Even though this is not 100% foolproof, it is something to start off with, right? Also, what we've done is we're going to start acknowledging our messages manually, meaning that we're going to wait until our actual, task is complete from the service and then acknowledge that they completed it. This is just in case a service does decide to fail or restart or something, that message or that task isn't lost, right? And then we also did the prefetch, and this is going to just distribute the messages more fair. I don't even know how you say it. Evenly, I guess. I don't even know, man. But you know what I'm talking about. It's going to distribute the messages fair. It's just going to wait until a task is acknowledged and then send out one if need be. I hope that made sense, guys, and I hope you learned something in this video. It's going to get more and more complicated throughout this series now. We're gonna actually start messing around with exchange types. So yeah, it's going to get a little bit more complicated now that we're starting to roll the ball. So be prepared. I hope you enjoy the video. I hope you learned something, guys, and thank you guys for watching my videos. I really do appreciate you spending your time watching my videos. It helps me a lot. Also, if you decide to support me, there are some links down below in which you can support me by, which is probably a donation or Patreon. Either way, thank you guys for watching my videos. I really appreciate it, and I will see you in the next video. Don't forget to subscribe, comment, and like. Bye.